All right, we are recording.
Welcome to the April 20th, 2021 session of TangerineSDR and Hamsci technical session. I always give the date based on UTC, just if you've wondered. And next, for me, let's see, I've been working on a number of little projects, none of which have come to fruition yet. And I do have some questions for Tom McDermott a little later, see if he has any clue to my idea. But anyway, so that's it for me. I've been doing a little bit of work, for leftover forestry work too. So that keeps me busy from my old career. So next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel, and thank you for helping with the password.
You are welcome. Thank you very much, Dave. Everything is going fine here. Just trying to keep everything going here at Scranton. I think we are on to the last third of the semester. So very exciting. And one good thing we were able to take, we still had money left over from the Hamsci workshop since we went virtual again this year. So we're converting that into student summer positions. So we'll have a couple students working on the radio telescope at the University of Scranton, and Kung, who joined us a few weeks ago. He will be hired this student to help out with the TangerineSDR FPGA work, and also hopefully help Dev with writing some scripts to distribute timing information from the chirp sounder receiver. So we'll see how that goes, but that's what we're doing.
Next on the list is Dev, KC3 PVE. Go ahead, Dev.
Hello, good evening, everyone. As Nathaniel said, we are starting a new week here in Scranton. I think it's going well. I have so we're making a new start, and personally, I don't think I have anything more to report. Thank you.
Very good. Next on the list, we have Jim, K4 BSE. Go ahead, Jim.
Good evening, all. Well, let's see. I've been working on assembling my Grape 1 PC board, probably about 3/4 of the way through with it. Ran into a little problem this afternoon, but I don't think there's anything that I can't overcome with just a little bit more time on it. Boy, those sure are small parts, even for surface mount. But we're getting there, and let's see. I have started trying to populate a little bit of stuff onto the help web page that Christina set up for us for the Grape 1. And I saw that Gary has just sent me something. I just saw that in the last couple of minutes after I was already on this call. So I will be taking a look at that. Thank you, Gary, and I will get back to you on that as quickly as I can. That's about it from here. Back to Net K4 BSE.
Fine business. Next on the list is John in 8 OBJ. I bet he appreciates the small part comment.
Actually, those are the biggest parts I could use.
Yeah, I know you couldn't use anything bigger, but
yeah, the 0603s and 0402s and the 0201s are just insane. 0201s are smaller than a speck of pepper. Yeah. This week, actually last week, was a major grind on getting out the document on how to set up the operating system image after you download it from the Hamsci website. And my little 2-hour project turned into 20 hours. I finally got it done Friday night. It is 7 full pages of meticulous detail. I sent a copy off to what's his name, and up in blank mind. Geez, I'm sorry, a complete blank here.
Dave Schwartz.
7UX, whose wife is having some surgery, so he's busy. And to
Joe. You sent it to Joe.
yeah, Joe, and then Dave Schwartz in Fort Collins, Colorado, who was out of town. So they're going to give it a run through and make sure everything works, and then we'll post that. It's pretty meticulous, and then I started realizing why it was taking me so long to set everybody up, because there's a lot of little gotchas and, oh yeah, you got to do this, and oh, I forgot about that. And that's all detailed in there. Also got some bandwidth on putting together the PC board, and when we get into the open session, I want to share the results of that. Back to net.
Fine business. Well, it's good to have that written down. Make sure you get it posted on the website.
It'll get put up there once somebody goes through it.
Yep. Very good. So next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. My sound okay?
Yes, just
Okay.
fine.
Good evening to you. Good evening to the net. Been working on a number of little projects this week. Struggled a little bit with creating a bootable grape image with GNU radio and digital RF. Keep having a problem with the chips getting corrupted on the file system table upon them burning. But I finally, after many tries, I finally got a grape image with GNU and DRF on it that uses the Adafruit GPS board to get accurate lat long and up to the second time and stores the lat long into the metadata on digital RF, and is tolerant of it if the board isn't there, and does a default. And so I'm preparing that. I will upload that to the UA box tonight so that Christina can get it. Also worked with the student team on getting the heartbeat code on the central control system. I have worked on this a bit using my own system with a VMware box running in my own shop here. But now we're finally to the point where we're able to test it with the big server at the university. We also got it working that the big web server can talk to a big backend database server, which has to be behind a second firewall, and then a demilitarized zone. You need to have all that anytime you're going to have something accessible to the general public. We've got the watchdog working so it can detect when data comes up. The way it is that each Tangerine system will heartbeat to the central control system once every so many minutes. And if the science super user has requested an upload for the ring buffer, the central control system will send a request for that to every box that does a heartbeat. And then as the data comes up using rsync, the watchdog will detect that it's there, will get the metadata, deserialize the metadata, then know how to put cross-reference information into the database so you can find it. Then the data has to be moved from the web server into the backend system past firewall number 2 for security purposes. So a lot of moving parts and all that. So we're still looking at a year before we have it ready for public testing. But anyway, we made a few breakthroughs on that, it's a good thing because our students, this is their last week for the year. We're one of those schools that finishes up super early in the spring, and we won't see them again until the second week of August. So my colleague in computer science hasn't, and he knows more about this than I do. So there hadn't been any student work set up for the summer that I'm aware of. So anyway, fortunately, we got this much done that where we can hit the ground running in the fall, working towards a running central control system. So back to net.
Fine business. And next on the list, we have Dan in for XW. Go ahead, Dan.
Oh, thank you, Dave, and good evening, everyone. Well, I don't think I did much last week. I think it was Tuesday, and then all of a sudden it was Friday. And I don't really don't really recall much happening in between the two. So I'm going to try to be a little more productive this week, I think. Well, that's about it from here.
Very good. Well, next on the list is Dave Witten, KD0EAG. Go ahead, Dave.
Nothing to report here. Back over to you, Dave.
Fine business. And next on the list, we have David McGaw, N1HAC. Go ahead, David.
Good evening, everyone. Doing a lot of different things, VLF, ground stuff. Our sounding rocket's been delayed by a few weeks to the end of May, it looks like, which is a VLF propagation experiment. I've also been working on a HF CubeSat that we're hoping to fly in a couple of years. Has both magnetic loop and dipoles on board, and we're trying to get the sensitivity up on it so we can pick up some of the emissions from the aurora that we look at from the ground and hoping to see from up at orbit. So been busy, but not so much on Tangerine per se, but all interrelated. Back to Net.
Well, fine business. And I forgot to mention, but there was a functioning optocopter on Mars today. So they at least flew a few feet off, or a few meters off the ground, and it seems to be working. So that's exciting stuff. We should be seeing more pictures soon. Next on the list is Don, KI5KGX. Go ahead, Don.
Well, thank you, Dave. Yes, this was a historic day early this morning at 3 a.m. The Wright Flyer, at least a very, very small postage stamp, pasted onto the bottom of the first flight vehicle on another planet. Quite a milestone for humanity. I did a little bit this week, actually some significant progress. I'm starting to study a benchmarking. You know, I see the tremendous work that the team has done in HAMSci, looking at frequency analysis in the ionosphere. And so I'm building up replicating the fine work that you've done, or attempting to, and spent a day attempting to install a GPS antenna for my disciplined oscillator, just moving the position. And I've come up with a theorem that age and height, they're correlated. The older you get, the higher you appear, the roofs appear to be. But we'll have to explore that model at another time. You know, this is all planned. You know, David McCaw, when you mentioned, time going on and how much you've done and looking forward, it's come to my attention in October 14, 2023, there will be an eclipse passing right over my home in Spring, Texas. And so I'm rapidly preparing for that event to do some frequency analysis of that. And David, like yourself, I hope to be ready at that time, given the studies. But that's enough for now. I really enjoy these meetings, and I've spoken enough. So back to you, Dave.
Well, fine business. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. As Jim said, I made kind of a first cut on the introductory document for the Gen 1 GRAPE. And Jim and I can go back and forth on that this week, tweak it a little bit. And then we'll see what happens on Thursday morning if we want to present it to the group, or what the next steps are. Back to Nat.
Fine business. Now, next on the list is Greg. Go ahead, Greg.
Yeah, nothing to report. I'm just listening in. Back to Net.
Fine business. And then let me make sure I didn't. It's always fun when the names jump around all over the place. Next on the list would be Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have much to report. I've been working on my book in latex, and my template is coming together. Other than that, not much else. Back to the net.
Fine business. And next on the list is Jules, K2KGJ. Go ahead, Jules.
Good evening, everyone. No activity this week for Tangerine. Spring has sprung and other things are calling at the moment. Back to Ned.
Well, fine business. And next on the list is John, KJ6IBP. Go ahead, John.
Hello, everybody. No traffic for the net.
Well, fine business. And next on the list is Michael, AA8K. We saw his old TNC earlier.
Thank you, Dave. Greetings to everyone listening. And Don, I think slope incorporates in that equation as well. The greater the slope of the roof. Back to you, Dave.
Fine business. And let's see. Next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Okay, Dave, thanks. Appreciate everything. And this week, let's see, got a couple magnetometers off to a couple of new people today. And also, we've got all the parts ordered for the RF module and for the clock module, and the common parts ordered for the data engine. So we have just the unique parts on the data engine. Only had a few, I think there's only one part we're having trouble with so far. And we'll see what we can do and work that issue. But unfortunately, the one part is the microchip part that is the Ethernet port on the data engine. And it's kind of a critical part. So, we'll see what we can do to find that. But other than that, we're doing pretty good. Although, you got to have all three boards to make a stack work. So we're hoping that we're going to not have to wait till November, like some of the parts we got in were the last of the parts that we need. So we got in right under the wire on a few of them. So that's again, we just have the data engine unique parts to complete, and that'll be done in the next day or two. So we'll know by next week's meeting what we're going to have trouble with and what we're out of the woods on. So I think that's it. Back to you, Dave.
Well, fine business. And next on the list is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave, everyone on the group. I've been working on GNU Radio a bit. No luck yet in porting to 3.9. Started looking at receiver characterization, getting ready for the RF module. I've been practicing on Hermes, and I've got a good procedure for characterizing the noise figure. And I'm working on one for dynamic range. It's a little difficult with Hermes because it's wideband receiver mode, puts out a vector of 16K samples, and then it's got many hundreds of milliseconds of idle time, and then another buffer. And that leads to some unusual results. Right now, the signal generator I've got is the Silicon Labs evaluation board for one of their parts. And it's nice in that I can put out any frequency. The bad news is it puts out square waves. That makes identifying the point of clipping a little bit challenging in the receiver since everything's clipped to begin with. So I have to figure out a way around that and get some good test equipment. Back to the net.
Well, fine business. I have since this is the end of the list, I'm going to take prerogative here, and I have a question. I got this from Steve Bible, a fellow who's working on a 1980s TNC, and he's looking for some software that does frequency crossing calculations. Do any of you know of maybe even some old Bell Lab software that does that?
Frequency crossing, does that have a definition?
Apparently he's doing analog processing, and he needs to be able to calculate the frequency crossing. The problem is he has a 1200 frequency and a 20, well, I guess 22 or 24.
Zero
22.
crossing, don't you mean?
Yeah, a zero crossing. I'm sorry.
Oh, okay.
So what happens is you can end up, because of the frequency distance, you can end up with an artifact that you don't know which one it belongs to. And so there's some code somewhere he needs to find. And he would, but it's all analog, so it's harder to find these days.
I mean, the typical way that those modems were implemented was to run a 1200 hertz signal oscillator and a 2200 hertz oscillator, and then correlate against the two oscillators. So when you get a 1200 hertz tone in, you get a lot of correlation with the 1200 hertz tone. And when you get a 2200 hertz tone in, you get a lot of correlation against that. And then you make one a mark and the other the space.
Right.
And so you get some noise reduction. And that's the way a lot of the modem chips ended up being implemented.
Yeah.
I would expect you could do something similar in software.
Yeah, I don't.
Was he just trying to decode it, demodulate it?
Yeah, he wanted to demodulate it, and he.
Yeah, because the old the old 760, I mean 560 series PLLs do very well for decoding FSK.
Okay.
I forget if it's a 566, 567, something like that.
Yeah, there was also an XR20, I think 2211
right
PLL that was a pretty good decoder.
Yeah, and I know that the 56X series are still around.
Okay.
Yeah, I've used both the XR and the Signetics, and they both work well.
Yep.
Okay. Well, I'll pass that on. I think he was looking for a software solution, but I'll pass that along.
Well, software would be a matter of oversampling it and detecting the.
Well, that was sort of the idea I gave him is.
Yeah. Because
my background statistics, I said, well, you just sample in there and you can then start to figure out which parts are of which feet, which line.
Yeah, because you're going to have like a 2-to-1.
Yes.
Change in the time between zero crossings. You put it through a comparator and then you sample it at 5, 10 kilohertz, whatever.
Yeah. So, well, I'll pass that on. That was my question for the open discussion. And anybody, we're open for any other questions.
I wanted to ask if, we've been raised up a flag on the part that we were looking for the VLF board. I put out some feelers and there are no parts out there that I can find. Has anybody else, Scotty or Jonathan, had any luck finding parts? Or even tried?
Put an order in the DigiKey for the NEO MAT GPS chip, and it initially came back with 180 day lead time. So I put the order in and got it in the queue. And last time I looked at it, they kicked it up to 192 days.
Yeah. Well, TI is saying a lead time of at least October on those parts. And there were some entities in China that were claiming to have parts, but they don't really.
Well, John, we in at OBJ, we have a stash of about 5 Neo GPSs.
Okay.
John does, and we're going to actually build those up into clock modules on the prototype run. So we'll have a few of the lower cost ones, if that will help you at all. But they'll be in our board, of course. So if you just need one to build a prototype, we could probably twist John's arm and see if we can get one.
When they get closer to needing that, we'll talk.
Okay.
I don't want to tear them out of your hands just yet.
Have you got any indication of when they're going to have them?
Well, from the status on the website is they're telling me, 186 months out. So
Yeah, I know.
Yeah.
I have problems with that because we had this problem with Altera in the early days, and what they do is when they don't know when they're going to get them, they just put 6
a
months
number on it. Yeah.
or they put 99 weeks because they have 2 digits, right? So
Right.
so, and I remember this happened to us. We ordered FPGAs for a project, and the FPGA is typically the most expensive single part on the board that you have to buy, right? So we order them, and they say, 99 weeks is some ridiculous lead time, and we say, but what's the real lead time? And then they come back and they say, oh, it's 18 weeks or something. And we're planning to build for delivery of parts in 18 weeks because we have to pay a big slug of money for these parts. So we schedule the rest of the parts to come in later, and they ship the parts in 2 weeks.
Yep.
Now, here you go.
Been burned by that so many times, they can't tell you.
You have none of the other parts. You can't build it, and yet you have to pay for those parts in 30 days.
Yep.
So it was awful. So we actually went back and complained, and they gave us additional terms to pay, longer to pay, because they kind of screwed us over in the delivery. So, I mean, getting in 2 weeks instead of 18 weeks, you think, great, that's what we want, but not after you've adjusted everything else.
Yeah.
So I don't know how long this is going to go on, but it's not very fun.
Yeah. Another thing I want to mention to the group is the programmer I had working for me through Nathaniel had to back out because he got overloaded with schoolwork, and his summer job is going to be demanding. So I don't have my C programmer anymore. So that was
John, what signals are you needing from the GPS?
I need the 1 PPS, and I need the NEMA data stream.
Yeah, there's so many other modules. You could just probably wire something in.
Well, I've actually got one working with the Adafruit module.
Yeah.
But I want to use the same module that's going to be creating the frequency synthesis for the PLLs.
Do you use 10 megahertz? Pardon me, use 10 megahertz also?
No, I can't. The Adafruit one just generates the 1 PPS.
Because you could use the inexpensive Neo part if you don't need 10 megahertz.
Because if it's a standard NEMA string that's coming out of the Neo part, I can just use the Adafruit part. That's the homework I haven't done yet. So
well, that means also you could use the inexpensive Neo part from U-Blocks on a clock module, and then you get the synthesizer.
Well, the other issue is the sawtooth variation in the 1 PPS, because the middle one only had 11 nanoseconds variation, and I think the cheap one had a plus or minus 50.
Okay.
Yeah, that's
is also what the Adafruit one has, is a plus or minus 50, and I want to get away from that. So that was the other thing I was kind of.
I see. But so you're trying to get the mid-grade sort of performance.
Well, that's great, except the mid-grade one blows your budget completely out of the water because it's half of what your entire budget is.
Yeah, well, if you want the performance,
I'm not. If you can't do it for $50 or $100 price tag, that's okay. But it just seems like if maybe there's a way to do it for getting closer to that by buying a $10 GPS instead of a $60 GPS.
Yeah, well, I think my $100 figure is not hard and fast. So
why do you need the PPS that accurate?
That determines the top a second for the 8 kilohertz sample window.
Right.
So it's also my clock setting.
Yeah, I wonder if there's a way you could work out a simple synchronizer that you can use a fairly raw 1 PPS, but use the 8 kilohertz as your primary.
Average it over like 1,000 seconds, it actually works out. But the problem is that requires extra hardware, and I'm trying to stay away from that. It's because if you look at the variations, they're all over the place. It's plus and minus, and it's just
so you can spend your money on a more expensive GPS and be done with it, or you can spend your money on additional hardware to do what the more expensive GPS does anyway.
Exactly.
Mm-hmm.
anyways, anybody interested in seeing my initial RF plot or amplifier plots?
Oh, yeah.
Of course.
Let's see if I can share a screen here. Did that show up? Let's see here. Your screen sharing is paused. Oh yeah? Why is it paused? Try this again. There. Everybody seeing a screen plot of my VNA?
Yep. Yep.
Okay, this is the output of it's basically a two transistor, two stage amplifier. It's a common emitter first stage and then a common emitter follower for second stage. I've got it set to a linear gain of 2.5, which is a 4 dB gain. And it's pretty flat from 10 kilohertz out to 100 megahertz. And I have the cursor set right here at 32 megahertz, which is on the top of the 10 meter band. And I'm down 0.1 dB at that point because it's 4 dB across, and this is 3 dB per division. So this is the 4 dB line. And at 100 megahertz, I'm down 1 dB. So it looks very, very promising. Even at 10 kilohertz, I'm down less than 1/10 of a dB. So
Did you say gain 2.5 gain of voltage or power?
2.5 in voltage gain, 4 dB in power gain.
That'd be more than 4 dB. Twice is 6 dB.
Well, that's power gain. Because the log of 2.5 is 0.4 times 10.
But voltage gain is times 20.
It's times 20, yeah.
No, so
that.
No, if it's a voltage gain of 2, that's 6 dB in power.
Yeah, well,
all in power and voltage, but it's actually 4 times.
Depending how you want to play with the numbers.
Okay, I'm just saying you've got
Yeah.
more gain than you think you do.
Yeah, but it's nice and flat, and the phase is fairly well behaved. And the way I set up the board, I'm going to be adding a little bit more gain. What I'm intending to do is tailor this amplifier to mate very nicely with that RF Pro 1BB magnetic loop antenna from DX Engineering, with probably 200 feet of the RG6 line on it, and give it a little extra gain. And this will also go very well for what Bill Engelke is doing for his distribution amp. This is working nice. This easily goes out to 50 megahertz, and I suspect with a little bit of pushing, I could probably take it out to 2 meters, but I don't know if he needs it that far. But it'll definitely go to 50 megahertz with no problem. But the first stab at it looks very promising. I'm going to change it around a little bit to have a little bit more gain to it. But if anybody's interested, that's what the board looks like. And then I sort of made it a general purpose board because I can change the first stage either to a common emitter amplifier by taking the coupling off the collector here, or if I populate this capacitor, it comes off the emitter as an emitter follower. So I can have an emitter gain stage here with a follower here, which is what I did. So this is the collector gain stage into a emitter follower stage into that. So, but I can make them both collector gains, and if I make this 50 ohms, then the output impedance will be 50 ohms, and everything's happy. And with the Q points all matched up very nicely. The only thing I don't understand quite how to do yet, and if anybody's got some RF design engineering with RF transistors, is I'm not quite sure when you have an RF transistor where you design the Q point for the lowest noise figure. By inference from a lot of the data sheets, the graphs and everything, it looks like it wants to be at 10 milliamps, because that's where they're showing everything operating at for the noise figure that they're speccing at. But it doesn't really, there isn't a noise figure versus Q point bias. So I suspect it has to do with bandwidth. quiescent operating point and some other things. So in any event,
Yeah, noise figure is fairly insensitive as long as you're within a certain range of the current.
because I know if you go too low in
Collector
the
current.
current, it gets
Yeah.
worse.
Then it gets noisy.
Yeah, and if you go up too high, then you run into power dissipation problems. So
Right.
so it looks like the sweet spot on this chip is about 10 milliamps, and this stage right now I'm running at about 7 mils. So
What's the transistor?
it is. I picked it off of. It's an RF transistor that's got a gain bandwidth product of about 7 gigahertz. It's I don't remember the number. It's some long number. It's not something you remember off the top of your head.
Right.
But I picked out 5 different ones, and I'm going to try all 5 of them and then run it through the noise figure meter and see how they do. But at least
John,
I got
I have a kind of a non-intelligent question. Is noise figure really significant at these HF frequencies given the background? Up at 144 and 70 centimeters. I mean, it's all telling, but I mean, how important is low noise on this preamplifier, as it were, at HF and
the noise figure is only important on the very first stage because that's where your signal to noise ratio is set. All amplifications beyond that, your signal to noise ratio, no matter what you do, it's already set. So it's really only important on the first stage. And if you're trying to pull stuff out of the mud, that's where it becomes important. For normal ham signals that you see on the waterfall, it probably doesn't make a big difference because the background noise is so high.
Yeah. Well, the point also is that at 30 megahertz, noise figure is important, and at lower frequencies, it becomes less important because the background noise, galactic noise and such, is much higher. But for using for small antennas, noise figure also is important. The actual noise, if you're using a small antenna, you still want to keep a low noise amplifier on it.
Yeah, the lower noise figure cannot hurt you, but if you have a high noise figure, it can hurt you.
Yeah, but certainly up at the upper range of what we're going to be doing, noise figure is important.
Yeah, I would agree. On that. It's with the small antennas, a low antenna efficiency, if you could put it that way, compared to more conventional, becomes a more significant, particularly, and I totally agree that the first amplifier after antennas is the make or break system. So I think I stand corrected. I am totally agreement with your rationale there.
That's usually why they put the preamp out usually right out at the antenna, so you don't have the loss of the line to decrease your signal.
Yeah,
that makes a big difference too.
I think I was doing that on the roof with my GPS antenna this weekend, and
so 1.5 gig.
Very familiar with that story.
Yeah,
and live to tell about it.
That's a good thing. Anyway, that's what I've been up to the last couple of days. See, I had a question for Nathaniel. Brain cramp. Oh, well, it'll come back to me.
That's good.
Yeah.
I saw Scotty just said that Bill wants a magnetometer.
I want to start experimenting with getting the data and figuring out how to put it into the metadata of the digital RF files that we're saving.
Oh, there's Bill. Question for you, Bill. That when I make this probably ×4 preamp, because this board is going to morph into a ×4 buffer amplifier for the antenna. Are you interested in 50 megahertz stuff, or is 30 enough? Because I just showed that I can go to 100 megahertz without any problem. Are you doing any 2-meter work or not?
Well,
my interest to knock it down as low as I can, just for keeping the noise levels down.
Well, I mean, when I'm doing 6 meters, I'm generally hooking the flex radio up to the 6 meter antenna. I mean, I did experiment a little bit with copying the mail today a little bit because 6 meters is open today, and was running some FT8 using the Tangerine semi-simulated prototype. No, I mean, for purposes of what we're doing, I don't think we need to fool with 50 megahertz because it's really not pertinent to the Doppler and all of the ionospheric work we're doing other than, I mean, if we want to start studying sporadic E, that's another whole project with it's got its own set of things.
I vote for 50 megahertz, but
what about you, Nathaniel, for your 4 radios? Do you need 50
saying
megahertz?
I don't need it, but whatever you
For
want to do
my
is
4
fine.
radios, I'm only going up to 30 megahertz right now.
Right. Okay.
But if it doesn't adversely affect the noise,
Because like I say, right now I'm down 0.1 dB at 100 megahertz.
yeah,
Just flat out. So it's going to be no problem getting 50 in there.
yeah.
And I just might start rolling it off at 60 or something like that.
I think that's not a bad idea if there's no real adverse effect with that.
And right now, I think, well, I'm down 0.1 dB at 10 kilohertz. Do I need to go lower than that? Your VLF?
No, you wouldn't need to.
VLF is at what?
VLF is, well, I don't know. Should let Jonathan check in. He might be doing work under 10 kilohertz, but it's generally going to be a different antenna anyway.
Yeah.
Well, and if you want to use it for the current RF module, we're 100 kilohertz to 60 megahertz. So rolling off above 60 would be a good thing.
Oh, okay.
And then
right.
And then
it's a general purpose receive only buffer amplifier, and I can change the name pretty readily.
But yeah, if if it can get down to 10 kilohertz, then it can get the submarine transmitters if you choose to.
Because it'll definitely get to 60
They're above 10 kilohertz.
WVB.
Yeah, VB would be at 60 kilohertz. The NAA is the big one around here, 24 kilohertz.
Okay.
Well, I think, Jonathan, I don't want to speak for you, but I think you're saying 10 kilohertz was your bottom frequency that you're interested in, right? Jonathan?
No, I want to go all the way down to 300 hertz.
There you go, John. There's your low end.
That's a low end of a whistle.
Jonathan's like, how low can you go?
Well, my VNA goes down to 5 hertz, so I can test it.
Right.
Yeah, the antenna that I'm using for all of my experiments is the MFJ 1886 loop, and it's 0.5 megahertz to 30 megahertz. So, I mean, the stuff that I'm doing, you can move coax around and switch antennas constantly, but it's really, for what I'm trying to do and developing the software to run the thing is not really pertinent. So,
okay.
Typically,
so
those
10 kilohertz to 60 megahertz is probably would cover everybody, most everybody anyway.
Yeah, for the really
You can
low.
always change coupling caps.
Yeah, and that's all it is in the front end is I changed that 1 mic cap to a 10 mic, and I got 10 times the lower end.
Yeah, for the really low end frequencies, those RF transistors don't have good noise figures. You have to go to a different device.
Yeah, good point.
Yeah, but they'll, they can. You might as well let it go down, and we can filter it elsewhere.
It's better to have it and play with it. Know you got something.
So I have a question for, I don't know if it's Scotty or for Dave. So I'm going to be having Kung work with us this summer. So what types of things would I expect him to be doing? How can he help or be a part of the project?
I would suggest he learn something about communication code. So the development board needs it needs code in there to receive the signals from the programmer or from the radio. And just because OpenHPSDR did it, we have set it at UDP. But I will tell you, there are some advantages with this faster speeds now. I wouldn't, if we could get the FPGA to talk TCP, it'd be great.
Good morning and welcome.
And
so
and there were examples in the Altera Intel.
So would that mean that you would be running a development board here and then trying to get TCP code, like a library that's already pre-written onto the development board?
Yes. Yes.
Okay.
And fix the library so that it works.
Yes.
Because it probably doesn't.
Okay.
Not to be pessimistic, but I've had bad luck with code that is supposedly IP that's canned that you can, that's included with. So.
But I would like to have him explore that side of it first.
Okay.
Because sending signals in and out is a big deal for us.
Does he have a software background? What's his background?
You know, I'm not entirely sure. I know he does have, yeah, we'd have to ask him more. I know he took the like the Verilog course or the introduction to FPGA course that one of the other professors here teaches. So he has some background there. I know he spends a lot of time working on like embedded software, embedded system sorts of things. So he seems to have like a personal interest in this sort of stuff.
Well, what Dave and I are going to need help with, I mean, Dave probably less than I will, but the embedded processor code, I'm not a software guy, so I can write Verilog, no problem. And I can instantiate the processor, but when it comes to writing the C code to do things in the processor, that's not my strength. I can muddle through it, but you know, somebody who has a software background that can do the C code for inclusion in the FPGA. And I think, Dave, you've done some of that.
Yeah, I've done some of that kind of stuff, but you know, there's a lot that depends on this bit of code, and I've done parts of it, but I've never done the whole stream myself.
Yeah,
I've done, and the way I'm writing my stuff is I'm making a radio simulator and the code, and making sure that the radio simulator does everything that I want the FPGA to do. And then I can show that to somebody and say, this is what it needs to do.
Okay. But there's really, there's really like three separate pieces of code, if you will. Okay, there's the code that runs on the host processor, and then there's the Verilog code that runs on the FPGA, and then the C code that runs on the embedded processor on the FPGA. That's kind of like the housekeeping director of the hardware that's written in Verilog. And those are really easily split into three definitive boxes, if you will. That and it's really good to have people experienced at all three of those.
And the other issue that's going to be a big part of this is the memory management. So he needs to be very familiar with it and know how to segment it. And I have some questions that I'm not completely clear on yet after reading things about how the memory management. So the kind of the naive simple one is you divide it into two big chunks and you work. But if we have the ability to write to specific spots in the memory, and
Dave, which memory are you talking about? The local?
Well, what I'm thinking of is we're going to have a whole bunch of different capabilities. because of the different kinds of things we plug in.
But you're talking about the flash.
Yeah, the flash. But I'm also talking about how do we manage 12 or 15 images?
Well, that's something external to the data engine, right? Because these are going to be different configurations of the data engine.
But if we could find a way that we can replace certain parts of that image space without in a seamless way, we might be able to simplify the number of images that we have to create.
And you might say a certain part of the memory is for NEOS code, and there might be a common area of that, like subroutines or something that we could include.
And you know, that way we can not overwrite stuff there and have ways that, like,
yeah, what you're defining is the minimal block.
Yes,
right?
that's what
Block
I want.
size.
I'm trying to say is
Yeah.
I want to have what the minimum block is and what are the dividers and where are those going to go and how do we map that?
And that'll be somewhat dependent upon what's the minimum block size you can erase, right, at a time?
Yes.
Okay. And I'm just thinking of, in terms of the C code, there's function libraries that you can build that you can include or not include. And a lot of them they give to you.
Yes.
And like if you, some of the function libraries are very large. And so like we had this problem on one of the project I was working on, that when we included the standard libraries, it wouldn't fit in the RAM anymore.
Right.
So we had to, so like we could use a get and a put, but we could not use a printf, that kind of thing. So you have to design your own functions. But then what you do, if we make them efficient, then we could put them in our own library.
Right.
And maybe compile different versions of that library for different versions of the FPGA code,
right,
so that we don't have a lot of waste. Because this doesn't have very much RAM. I mean, relatively, and compared to a PC, it's very limited.
So, so what's not a lot of RAM?
256 megabytes.
Okay.
So, I mean, that seems like a lot, but it gets chewed up pretty fast when you start adding in routines and, you know, IP.
Right.
And the problem with the one I was working on before that we ran out of RAM is they did not put any external RAM, hardware RAM in the system. Well, we didn't do that because we know that you need external RAM if you're going to have lots of software. So what has to happen is you have to have room to store the program, the NEOS code, which is NEOS is the software processor. So you have to have room to store that code in external ROM in flash. And then when you boot, you copy that into RAM and you run it out of RAM. Now, yeah, okay, you can run it out of flash, but it's horribly inefficient and slow. So you want to have big RAM and almost as big ROM.
Okay.
So that's what we do. We have a lot of ROM, we have a lot of RAM, but not unlimited. So
there's several things for him to learn, and it'll be interesting to see what he comes up with when we get to the part of doing it. Reading all this, it seems like we should be able to build something that works. But I also know there are lots of gotchas.
Yeah.
Well, and the thing is, if he's familiar with how to program FPGAs and how and Verilog and how to do a NEOS processor and how to program the code for a NEOS processor, then what's going to happen is we're going to be building something. We're going to get stuck somewhere. We're going to have a problem. Something doesn't work. Something doesn't fit. Something so it'll be a problem that has to be solved. And none of us are going to know how to solve those problems ahead of time. It's going to be like my old boss used to say at the beginning of a project that he needed a list of specific unknown problems that we were going to face. And after we got done laughing at him, he was kind of like, well, he doesn't understand why are we laughing. It's like, you know, and I mean,
how long it's going to take to solve them.
That's right. That's right. And that's the thing is he wants to know how many work days it's going to take to solve them.
To solve
the unknown unknowns,
unspecified problems.
Hey, isn't that the definition of what an academic does?
What's that? Solve unknown problems?
Yes.
Yeah, well, that's okay, but I need a list of them in ahead of time.
Yeah. So do I need to buy Kung some development hardware?
Yeah, what do you think,
What do we
Dave?
need to
Maybe
get him?
Well, I would start
Jurassic
with
kit?
that Jurassic development board.
Yeah, you want the name of it?
Can you email it to me?
Sure.
Like,
Or I
can
can
you?
put it in the chat, whichever.
You just email it to me, then I have it forever.
Okay.
Forever. That one? Scotty?
See?
Is it that one?
No. It's the one with two Ethernet ports on it.
Oh, okay.
It's
That's whiz bang one.
It's $200, right, Dave?
Yeah, this one's only $50.
$200.
It's $200. 100. Hold on, 189, but it has a
nice big box.
It has a Max 10.
That's it.
50.
Max 10. And it's
okay. Where I'm looking
Altera is on the box, but I ordered mine from DigiKey and they called it Jurassic.
Yeah, and it's called just the Max 10 development kit, and I'm looking at it on Jurassic. But yeah, you're right, Dave. Ordered on DigiKey, much better, because it costs the same price. And if you can believe this, the guys from Jurassic wanted me to sign some kind of deal that I wasn't going to design it into a product. And it's like, no, that's not what I want to do. But yeah, Dave, when you bought yours, they didn't give you any problem. They just said, hey,
no,
right?
It was like somewhere
How many
around
do you want?
$250 or something.
Just a second, I'll get it for you here.
So is that the only thing he needs then?
Pretty much to get started, yeah.
Yeah.
Let's see. That's not being nice.
They should be able to do that.
That and an older version of Quartus, because I think the very newest version doesn't support the Max 10 anymore.
Oh, that better not be true.
Well, we're
That
using
better not be true, Sean. Would
20.
you load the latest versions and find that out? Because
I'm running 18.1 right now on all my lab computers, and I'm
you
not
have to load. You may have to load the Max 10 file separately.
Right.
You do.
Yeah, but the Max 10 is like only one down from their newest Max part.
Oh, okay.
So-
I must
so
be thinking of something else then.
I would see Cyclone 4, maybe it doesn't support anymore, but
No.
And
oh, don't
Cyclone,
give me a heart attack.
you got to go back to 9 to do Cyclone 3s.
Yeah, that's right.
Yeah.
And that's what's on the Hermes, right? So you
Right.
gotta go back to, let's see, evaluation boards.
Well, guys, I got a split here, so I will say 7.3s.
7.3, John.
73,
Good night, John.
Everybody stay healthy.
Yep. Oh,
Okay.
Dan's got one.
Yeah, that's it right there.
And so
You mean
here we go, Dan.
you mean like this one right here?
Wow. I feel left out over here.
I do too. I need to order one tomorrow. Don't know what to do with it, but I feel like I need to have one.
You just have to have one, right?
You have the thing and you sit and say, now how do I make it work? And you can do blinky lights with no trouble at all. But when you have to do real work, it starts to get difficult.
Complicated.
Yes.
So I have to
Is
hand it to a student.
Is the NIOS code on that running on an RTOS, or is it running in on a minimalist Linux kernel, or how's it sit?
I think it's an RTOS.
So because that's a whole world of development all on its own.
Yes.
Well, it's actually what we're using is more like bare metal. There's not really an OS. You write the code that you want it to run on. There's no, but they give you a bunch of libraries with functions, so you can build your own. But there's no. I don't think there's an OS.
It is very confusing to work through it. And you took the class, you and Dan, didn't you?
I don't think we took the class on this board, did we, Dan?
We didn't take one on the Max 10, but we did do, remember we did do a class on, I think it was on a Cyclone 5.
Oh. Oh, that's right. When you're doing the IQ too.
Okay, there's the DigiKey part number. They got 69 of them in stock. They're $199.
We'll sell several for them tonight.
That's right.
Everyone will have one by tomorrow.
And if you
Good one,
want,
guys. I'll see you next week.
See you.
Take care,
Thank you,
Jules.
Jules.
Take care,
Particularly
73.
there's the link.
Oh, great. Thank you.
I'll email it to you too, Nathaniel, so you'll have it forever.
Thanks.
Say.
I can have Lori order one and have it ready for Kung.
Well, hopefully he can figure it out. And if he's done some of this before,
It's likely to
Yeah.
be a bit of a swamp.
I think it is.
It's not trivial, but you got to start somewhere. And if he wants to participate, you better start now. And you know, and I'm sure it'll be a great learning experience for all of us. So, but it uses the same RAM that we use and the same FPGA that we use, different package size, so it has more restricted I/O.
So how much experience do you have with this?
Well, let's see. I have a fair amount of experience making dual boot systems with this board here.
Okay.
And then I have quite a lot of experience with Max 10s because the last 3 projects we've done have been all Max 10s. So, yeah, so it's this is the one day, I don't think I sent you these, but I had the 2 programs that flash the LEDs at different rates. And
You
then
didn't send those. I was waiting for them.
Oh, I'm sorry. I get bogged down and I forget, you know. So so I got it set up so we can do dual boot, and then you can push the button and you can boot the other one.
Yes.
You can push the button and you can boot back.
What I was started reading about it, and I started wondering, and I never got a clear answer from my reading, is this whole idea that I was trying to pitch to you was, is it just 2 chunks, or can we work in ways that allow us to be more flexible with minimum blocks?
You can be flexible only to the extent that they let you. And it's not as much as you want. I can tell you that right now.
Well, I know
I think
that.
you'll be doing well to have 2 that work well.
But what scares me about this project is having 15 or 20 different configurations and maintaining those.
Okay, but the way I'm looking at that is I would welcome 15 different ones, but I would welcome
That means somebody's using the board.
Well, but I expect to have 15 different champions, you know, 1 for each one.
Right.
Right. So, you know, if you're going to have 15 versions, you better have, you know, 100 people working on them and not just like you and me. Otherwise, we're going to get like totally. So for the Space Weather Station, I'm hoping we're going to have really only 1.
Right.
And then when you want to use it for a VNA, you'd have a different one. You want a high performance HF receiver, you have another one. And you can download these with the code that you and I are going to test at will, and it'll be fast without having to load 3 gigabytes worth of Quartus.
That's right.
And so if you can make it fast, so it takes 10 seconds to reload, then really who cares how many there are as long as the developers take care of their own.
Well, the code that I'm working on is as fast as your bandwidth and the memory that'll suck it up on the other side.
So I didn't get
in
that.
the development board.
So you can keep up with the development board is what you mean?
I believe so.
Okay.
Well, either that or the bandwidth.
Well, I don't think that the gigabit Ethernet is going to be the problem is going to be the flash erase time.
Yes.
And actually the problem we saw in programming the flash, it takes about, I want to say 30 to 45 seconds to program the flash. And part of that, I think, is because of the commands that they give you are clumsily written. They're not optimized.
Okay.
Because all they want to do is get it to work. And this is just a development board. But now for us, we want to be able to do it a little bit faster. But unfortunately, we might be stuck with their IP when it comes down to the base level. I want to erase that sector. You have to give the command and then you got to pull it looking for the result, and you just can't go any faster than when it comes back and with
That's right.
the busy.
And that was the thing with the open HPSTR was erasing took a while. And then once you erased it, to know that it was ready to do the next step, it was confusing to a lot of novice users. Of all the boards, people would write me and say, oh, we bricked the board.
Oh.
And the thing was, it
Another
wasn't
thing
bricked.
you don't want to do.
Well, it wasn't bricked. It just, you aren't patient enough. I think out of all the boards I had, there's a handful that I couldn't fix.
Well, one of the things that we were doing on the last project I worked on is that we're sending the data over a serial port.
Right.
And so that almost doubles the amount of time, because we calculated the amount of time it takes to transmit the data at like 38 4K
Yes.
is roughly the same amount of time it takes to do the program.
Right.
So you're doubling, and you can't overlap those two, although you can, if we had enough RAM, which we do, and that they did not, we could double that. We could have that, because we could be transmitting the next block while you're programming the previous one.
Right.
But what we found out was that the erase is not the long pole in the tent. It's the program.
The programming, writing all those sectors.
Writing all those sectors. And I don't know what the holdup is. It should not be slower than the erase, I wouldn't think. But, you know, when you get down to the level of here's the minimum thing that Altera gives you to work with, then you're stuck working with that, and you can't.
Is it possible that the slower write time is slower than erases, that they're verifying it?
I mean, it probably is.
And that's going to double.
Yeah.
It could be.
Potentially double it.
Because basically you give it the write and then you wait. And
Yeah.
you wait until it says ready. And until it says ready, you better not be doing anything else.
Yeah, with something like this, you got to verify it, because you can't necessarily be 100% certain that no write errors.
And then the command to do the write is something that is built into the FPGA that it's a function that you call. So you don't get to write any code to go down any lower level than that, like saying, oh, well, I'll just write to the cells directly. You can't do that. You're stuck with using their IP to talk to it. So that's the lowest level you can get. So, but I don't think that's really that's just a time thing. And when we get the handshake in, Dave, there's not going to be like send the whole block, and then after if the third byte's bad, then you just wasted all that time, then you get a knack back. We're going to go by sector, right?
Right.
So, and in fact,
well, and one thing that John did in his code is he used very small packets, because he was having trouble initially. And I think we can use as big a packets as it can take.
Well, depending upon the bootloader, I think we have enough RAM. We could load the entire image, download the entire image before we programmed anything.
Okay.
And once you get the image in RAM, it ought to be virtually fail-proof to program it.
Right.
Because the errors are going to occur on the communications, not
communications link. Yes.
So once we get the communications that transmits the whole FPGA image over to our onboard RAM,
right.
And then the bootloader takes care of the algorithm that goes and programs that into the flash.
Now, here's the question I have for you and Bill. I'm assuming that we're going to have a person in the room with the board programming it. Now, is there some allusion to having the central host send out a new version of the code, of the firmware?
How would you?
Are you saying?
How would you? Doesn't it have to be that way?
I think it has to be. What do you mean? Which
Talking about two different things.
The local host is the one that's in charge of what programming.
So it has to be at the local host. And I'm just curious, because a lot of this stuff, running it over the network would be a pain. Over a long network. You're running it.
So Dave, would the question be whether the reflash is attended or unattended?
I guess that's probably the question.
So could you do an SSH into the local host and cause a flash from Afghanistan if you wanted to? Cause a reflash.
Yeah.
Is
And
there
do
a
we want
feeling
to
there's
do
a
that?
need to? Do we need to have that capability?
Well, the problem is not so much that, but there are folks that try to program these boards and it doesn't work perfectly through the process, at least in the old system, and then hopefully we can improve that. But if it doesn't work, if it stops in the middle, people don't know what to do.
Well, here's the thing. I mean, we've got the advantage of a pretty smart system in the local host in that, for example, we can distribute firmware for the FPGA. We can distribute that through various means. It can be on a Debian distro. It can be sent from the central command control system. And now it can be stored on the local host. You can even have a library of different flash things. And now, well, I mean, it's theoretically possible that we could have the central control system tell a local host to reflash somebody's FPGA, but if I was the owner of that, I wouldn't necessarily appreciate that. So
I don't think I particularly wouldn't, but I do know one thing that we usually get in this section is there are people who get confused at what they're doing and they make steps out of order or something like that, and then they need help.
But Dave, we're not going to let that happen this time because it's going to be so simple that you're just going to click a button and it'll be done.
Well, I'm just telling you.
I see a couple of different issues here that we may be kind of merging together.
Yes.
One issue is we may have unattended sites, for example, Antarctica.
Yes.
Right. And in that case, you would want the opportunity perhaps to do an unattended upgrade.
Yes.
Right, where the central host could flash something that is 1,000 miles from the nearest person. On the flip side, you know, it may be in your house and you're there and you might want to have positive control over the upgrade. And so I think we may want to break this into a couple of pieces. One piece is how do we get a good binary image downloaded to the local host? You know, that may be a binary with a SHA-256 on it or something like that to guarantee that it gets there okay. And then we may have a checkbox in the configuration which says permit or don't permit unattended upgrades.
Yes.
And then if we have an attended upgrade, you know, we can say, here's the place in the directory where we found all the images, all of which have good SHA-256s. Which one do you want to program? You know, maybe we want to break it into that kind of a level instead of the others. That makes sense.
That makes a lot of sense.
Yeah.
We also have hardware on the board that I'm talking about a jumper. We have about 7 or 8 jumpers, and you can assign one to say lock and don't allow any hardware upgrade, any FPGA upgrades. So similar to the checkbox that Tom just mentioned, only a hardware one that says, I'm going to program this and I'm going to put the jumper on, and then nobody is going to mess with my FPGA.
Yeah. So like if you make that whole, you've got to make a way that you can block it, because there are people that, and I would probably be included among them at times, that want to not have that change.
And if you're going to put the local host kind of in charge of the library management, if you will,
yes,
then you may be able to even make hierarchies and say, okay, if I'm a personal space weather station, then I'm going to allow the cloud to load these images, or maybe I have them on file and it can pick between them. And if I'm not a personal space weather station, then I don't have that hierarchy, and you can't.
But a good example is Nathaniel might be managing 10s or 20s of these boards in different places and you want to do upgrades or maintain them, or your student or whoever it is, but you want to have a way that you can control
Do it
those.
remotely.
Yeah.
Yeah.
And I actually need to sign out here because I'm supposed to stop in at a another telecon.
You look like you're falling asleep right
I am, but was it Mike Zurch from University of California, Berkeley?
Oh, it's
he-
earlier for him.
Yeah, it's earlier for him. So he asked me if I would kindly come in, and I said I would. So I'm gonna go say hi to his class.
Okay.
And then I'm gonna go to sleep. So thank you so much, everybody.
Okay.
Appreciate it.
Okay, 73, Nathaniel.
I will leave, I guess, Scotty, either Scotty or Dave in charge here. So.
Okay, and I'll send you the link to that board, Nathaniel.